Welcome to Web Handling. My name is Dave Roisum. In this clip, we talk about some of the unique challenges of troubleshooting baggy foil or sheet metal. Foil, sheet metal, and other materials are made by rolling. To understand bagginess with respect to rolling operations, you must first note that many materials are incompressible. This means that if thickness is reduced, it must show up somewhere else in direct proportion. This something else is not density, because metal is incompressible. This something else is also mostly not width, because rollers constrain width creation. The something else created by thickness reduction is length. The next thing you need to know we learned in our Web 101 class. That is, bagginess is a variation of length across the width. Therefore, if thickness is reduced unevenly, then length must be created unevenly, hence bagginess. So, while most baggy materials are made flat but have an uneven thickness profile that is stretched into bagginess upon winding, foil and sheet metal can be made baggy at the point of manufacture and do not need winding to make it worse. Another concept that we need, especially in regard to foil and sheet metal bagginess, is thermal profiling. From our Web 101 class, we understand that rollers deflect and that we may wish to crown them to counter deflection. We even have an app to calculate and correct the crown. Also from our Web 101 class, we learned the risk of temperature profile variations. Here, we will just add that occasionally temperature profile might be intentionally varied to our benefit. If, for example, we have a relatively thick middle in the web, we could heat the rollers up to expand the diameter there ever so slightly. That will smash the thickness down more there. In metal, thermal profiling is done via water spray quench. They also use different words for bagginess, such as center buckles and edge wave, but the concepts are identical. Of course, all good web handlers should be shaking and shuddering at this point. The reason being is if there is an element that can correct bagginess, it may also create bagginess with even greater ease. We end with a discussion that also has parallels between both metal and paper. That is the idea of leveling or decurling. In both cases, we are cold annealing the web to reduce residual stresses from upstream manufacturing in the hopes of making the web flatter. In metal, this is done by repeated reverse bending over rollers. In paper, this is done by repeated reverse bending over either rollers or radius bars. While the tendency is to greater flatness within reasonable incoming challenges, there are some important trade-offs to consider beyond the cost of the equipment. That is, if you bring a material into yield, you will increase the risk of damaging or even breaking the material. In paper, this might be cracking the outer fibers or coating. In foil, this might be web break. Thank you so very much for watching this module in my Plant Practical video series. Stay tuned for baggy web troubleshooting challenges unique to other web materials. Also, please be sure to watch earlier clips in this series as well as Web 201.05 through 09 as preparatory background. Oh, and of course, you should have all taken my Web 101 short course as essential background for any web challenge, and especially baggy web challenges.